Hi everyone, this is Shubhashati with Shiv Solution. This is the video by the troubleshooter of your mass phobia. If you feel it's worth of watching, please take a second to hit like and subscribe to our channel. Well, dear students, let's start vector algebra with weightage. If you are a Karnataka board students, the weightage of this chapter for the exam point of view will be 11 marks. So there will be 11 marks for the final exam, in which there will be one marks question, and there will be two marks question, and there will be two 3 marks questions. If you are a CBSE students, we can expect, dear students, 6 to 8 marks from the vector algebra. Okay, let us just start this chapter with the introduction. The first thing we are going to start with introduction. So along with that, we are going to study the types of vectors. So with this, we are going to study the algebra of components. In that algebra of components, there will be two things. One is addition of vectors, and another one is multiplication of vectors. So along with this, dear students, let's move to the next one, that is product of vectors. So in this product of vectors, there will be again two things, that is scalar product and cross product. So now the last concept, what we are going to study in this chapter is very important for the 3 marks, that is scalar triple product. That is scalar triple product. Okay, dear students, let's move to the further. So that is, as we all know and which you have studied in the first PUC physics subject, that is, there will be totally two categories of physical quantities. Correct? There will be totally two categories of physical quantities, in which the one may be scalar, not maybe, sure. So one is scalar quantity and another one is, may I expect from you, dear students? Yes, no doubt, it is a vector quantity. So what is scalar quantity? Can I expect? Yes, dear students, a scalar quantity is nothing but it is a quantity, or it is a thing which is with only magnitude, So a quantity with only magnitude, that we call it as a scalar quantity. Example, I hope you can see here, temperature, mass, volume, work and period. So everybody is this that sir, here the temperature is 18 degrees Celsius in west direction or in east direction? No, not at all. So nobody do that. The same way, period. I mean your age. So you'll be saying that your age will be 18 years or 17 or 19, whatever it is. Is there anyone that to say that, sir, mine is 18 years in the east direction, 17 years in the west direction? No, no chance at all. Correct, dear students? Yes. So next move to the second category of physical quantity, that is vectors. Can I expect the answer for this from you people? Yes. So vectors is also a quantity. Vectors is also a quantity in which it is a, yes, can I expect? So it's a quantity with magnitude as well as direction. So that means what I'm trying to say here, vector is a quantity which has magnitude and direction. It has both magnitude as well as direction. See, it has magnitude as well as direction. Whereas scalar has only magnitude. It's one value. Scalar, it has one value. It has only one value. Okay. Whereas in vector, it has a value along with the direction. It goes in which direction? There is a value in which direction. Two things are there for the vectors. So example for the vectors are which you have studied in the first year or in the high school itself, in the physics subject, that is velocity, displacement, force, acceleration, even torque. Go on. Okay, dear students, let's move to the what is vector you have come to know. So in this whole chapter, we restricted with the vectors only, dear students. We are going to study only the vectors things in this chapter. So let's move. How will be the vectors? The first thing is vectors are represented by an arrow. Vectors are represented by arrow. Please have a look at this diagram. This is the arrow. Okay, dear students, I think you can get a clear idea that arrow represents. Right? arrow represents or arrow indicates the direction of that vector. It goes in which direction, that will be represented or indicated by the its arrow. So here, please have a clear look. Just see here, it has a 2 points, correct? It has a 2 points, A and B, point A and point B. So all the vectors will be with the 2 points, in which the point where it started, that we call it as a initial point, as well as where it ends, that we call it as a terminal points. Dear students, it's very important. In vector, or a vector has 2 points, in which the one will be the initial point and another will be the terminal point. So here I take A as the initial point and B as a terminal point, and then finally AB. I will take it as a vector AB. This is the way I represent. So the first will be the initial point and ends with the terminal point. This is the way I write the vector AB. Then, so as already I said, B is the terminal point and A is the initial point. Then the distance between these 2 points, which 2 points? Yes, the distance between initial and the terminal points, we call it as a length of that vector, or we call it as a magnitude of that vector. So please keep in your mind the distance between initial and to the terminal point, that we call it as a magnitude or length of the particular given vector, and that will be denoted by, see here, that will be denoted by magnitude of AB. Magnitude of AB, or you can also represent it by the any of the small letter of English alphabet, any of the small letter of English alphabet. And here I'm going to take it as a vector A, magnitude of vector A, or normally you can write this. Well, dear students, let's move to the next concept. So if you categorize the vectors, there will be two categorization in the vectors. So which are they? So in that two categories, we are going to restrict with one category only, but let us check it out. Which are those two categories? In that, the one is localized vector, and the other one is free vector. So what is localized vector? Let us check it out. What difference is there in these two? How can you distinguish these two vectors? Very simple, dear students. A localized vector is a vector where its initial point cannot be shifted. You can say whatever you can say in a different way, but I'm trying to say in this way that you can't shift its origin, or you can't change its origin, or else if you want to say another way, means the origin will be always mentioned in a particular origin it has. Through that origin only it has to draw. That we call it as a localized vector. Whereas the free vector, the next one is free vector. So what is free vector? Very simple. I hope I can expect if you compare with the localized vector, the answer for free vectors I can expect from you only. Can I? Yes, it is also a vector where initial point can be changed or can be shifted. Wherever you want, that initial point you can draw it from wherever you want. Okay, that's the things. And please keep in your mind, we are going to study through this whole chapter only the free vectors. We will discuss with only free vectors. Okay, dear students, let's move to the next concept. That is very important for one mass. Definitely there will be one question from this for one mass. So that is types of vectors. So there are some types of vectors are there, students. Let's start with our favorite number. That is 0. Right? Is our favorite number correct? Yes. So 0 vector. Let's start with the 0 vector, which can be called it as a even null vector. So what is 0 vector? Very simple. Just take a point, initial point A, and I will take another point A only. So now here initial point is A, terminal point is also A only. Means, so where it started, there only it ends. That we call it as a 0 vector. So that means the initial point and terminal points, when it coincide each other, that kind of vectors we call it as a 0 vector, and it will be denoted by zero vector. It will be denoted by zero vector. So dear students, please keep in your mind here the vector AA or BB, whatever it is. So whenever the initial point and terminal points are the same, that we call it as a zero vector. And please keep in your mind, zero vector cannot be assigned with any direction. Zero vector cannot be assigned with any magnitude. So since it doesn't have any direction, so we can't define it with any magnitude. It has a zero magnitude. Okay, let's move to the next one. That is unit vector. Unit. A name itself indicates what is the meaning of unit vectors. So what is a unit vector? A unit vector is a vector with length 1 unit. The length of this unit vector will be 1, or you can say that a vector with magnitude 1 or with the magnitude unity, we call it as a unit vector. So dear students, it's the many times there will be one question related to unit vector. They may not ask the types of unit vector, but related to this unit vector there will be a question. Okay, let's further we'll study that one. The unit vector, suppose if they given here any one vector, vector A or vector B or vector C, if they ask find the unit vector along with the direction vector C or in the direction vector C, means that will be C cap, represented to be C cap. So unit vector in the direction of vector B means that will be denoted by B cap. This is a way of representation or denotion of unit vector. Okay, this next types of vector, that is co-initial vectors. Please have a look at the diagram. Next one is co-initial vector. What is meant by co-initial vector? Very simple. Just here is a one point. I'm going to draw one vector through like this, another vector like this, next vector I'm going to draw like this, next. So now tell me, how many vectors you have drawn through a single initial point? Yes, I have drawn more than 2 vectors through the same initial point, correct? So this only we call it as a co-initial vector. So co-initial vector is nothing but as vectors. Please, I'm telling here vectors. Vectors means more than 2 vectors. Okay. So vectors having same initial point, that we call it as a co-initial vectors. So along with co-initial vectors, there is the next types of vectors is collinear vectors. That is collinear vectors. Please, you must be able to distinguish the types of vectors. Don't be confused with the types of vectors. Okay. So next thing is collinear vectors. What is collinear vectors? Same again, I'm telling you vector means more than 2 vectors are there. Okay. So I think by looking at this diagram, you will be able to see what will be the collinear vectors. Okay, anyway, let me explain that is. Collinear vectors are nothing but it's a vectors which are more than, whenever the more than 2 vectors of which are parallel to itself or parallel to each other, Let it be 1, 2 vectors or 3 vectors or more vectors. No need to bother about its magnitude and direction. Whatever direction can be opposite or in the same direction. But the compulsory, the thing is, it should be parallel. But you no need to bother about its magnitude as well as direction. Let it go opposite direction or in the same direction. Let it be 1 centimeter or 3 centimeter or 5 centimeter with a different magnitudes or length. But if it is a parallel to each other, then we call it as a collinear vectors. I hope it's clear. Let's move to the next type, that is equal vectors. This is the difference between, just careful, the difference between collinear and equal vectors. Even equal vectors also you can call it as a collinear vectors. The difference is here, both should be in the same direction. I mean, in the equal vectors, if you take 2 vectors, the both should be same magnitude as well as the same direction. In collinear, it should be parallel. That's the condition. But in the equal vector, it should be parallel and it should be equal in magnitude. I mean, length to samanagirebeku. So along with that, as well as it should be in the same direction. Yav direction one vector ideo, matton vector ade direction irbeku. So your condition is idu parallel ಆಗಿರಬೇಕು, equal ಆಗಿರಬೇಕು, same direction ಹೊಂದಿರಬೇಕು, ಮತ್ತೆ magnitude ಸಮಾಗಿರಬೇಕು. So ಹೀಗಿದ್ರೆ ಮಾತ್ರ we call it as a equal vectors. I hope it's clear the difference between these 3 vectors, correct? Okay, now let's move to the next one, that is negative of a vector. That is negative of a vector. So what is negative of a vector? Very simple. Just see here. Here is a vector AB. So your initial point is here, terminal point is B. So if you write the same vector in opposite direction with the same magnitude will not change. So when a vector goes in entirely opposite direction with the same magnitude, then that two vectors we call, or the new vector we call negative of the old vector. So I mean, if vector AB is given here, if vector AB is vector A, then the BA. So here initial point and terminal get replaces, then it will become minus vector A, means direction is opposite. Direction is opposite. So when the two vectors are with the opposite direction with same magnitude, that we call it as a negative to each other or negative of a vectors. Okay, now let's move to the next one, that is like vector and unlike vector. There are two more vectors, that is one is like vector and unlike vector. So just let me get a clear things that make you clear that like vector means what, and I want to get the clear from you people that unlike vector means what. Okay, so this is very simple. Like vector is nothing but a vectors. Same vectors with same direction. The vectors with the same direction we call it as a like vectors. No need to bother about anything. Simple. ಯಾವ ವೆಕ್ಟರ್ಸ್ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೋ, ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೋ, ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅದರ ಬಗ್ಗೆ ವರಿನೇ ಮಾಡಬೇಡಿ. So which vectors are with the same direction, that vectors we call it as a like vectors. ಹಾಗಾದ್ರೆ unlike vectors ನಿಮ್ಮದು ಎಕ್ಸ್ಪೆಕ್ಟೇಷನ್ ಮಾಡಬಹುದಾ? ಏನು? Fully opposite to like vectors. That is vectors with opposite direction. Vector with opposite direction irrespective of their magnitude. Okay, magnitude no need to worry, but which vectors are with opposite direction, that we call it as a unlike vectors. That we call it as a unlike vectors. Okay, I hope it's clear. And this thing you have to know, please. Vector AB which never be equal to vector BA. Vector AB which never be equal to vector BA. Okay. So next, the important thing, that is position of a vector. Position of a vector. What is meant by position of a vector? Simple difference. Let me take a point P. Any point if you want you can take. I'm going to take the point P. So point P of the coordinates x, y, z. I mean the point P has the x impact on x-axis, y coordinate impact on y-axis, and z point of impact on the z-axis. So I have taken a point P somewhere in a space it is. Okay, I have taken a point P in a space. Okay, then with respect to origin, I take it as a vector r. So now I want the position vector of point P. I want position vector of a point P which is in the space with coordinates x, y, z is OP, vector OP. So if here, just here is the point A, correct? Then the position vector of point A is vector OA. Very simple. The position vector of point B is vector OB. This is the way we represent the position vector. Okay. So in this position vector of OP, you can also write it as a, normally we take it as a vector R. Vectors are small letter R. So I hope it's clear. Position vector is okay. So position vector will be always we take with respect to origin. With respect to origin only we need to calculate the position of the any point which is given in the space. So then next, then I want, if you got the position vector of this point P, then what's the length? I mean magnitude. So the magnitude of OP will be equal to root of x square plus y square plus z square. How we get this means, this which we have studied in the first year 3D chapter, one of the 3 marks, one of the important theorem you have already heard. Okay, well dear students, let's move to the next very important concept. I can say that because which continues in the chapter 11, 3-dimensional chapter. Okay, so what is that concept? That is direction cosines and direction ratios. To make you clear this concept, dear students, please have a look at this diagram. Again, I'm going to take the point P in a space with coordinates x, y, z. Now the position vector of that P is what? That is OP, correct? Then the position vector of that point P is OP will be represented by vector R. Now just please have a look at this. This OP is making an angle alpha with what? X-axis. Beta with what? Y-axis. Gamma with what? Z-axis. Here that vector OP, the position vector of point P also I can say, or vector OP is making an angle alpha with the x-axis, beta with y-axis, and gamma with z-axis. Correct? Then that angles alpha, beta, and gamma are called direction ratios. Direction ratios. That three angles only we call it as a direction ratios. Similarly, I want next what is direction cosines, correct? Next concept is direction cosines. Very simple, dear students. Just take the cos of these angles. Just take the cosines of these angles. I mean cos alpha, cos beta, cos gamma. The cos alpha, cos beta, and cos gamma. If you take the cos for these three angles, that angles we call it as a direction cosines. Direction cosines. Please note the point what I'm trying to say here now. These direction cosines will be always represented by L, M, N. L, M, N. I mean cos alpha will be represented by L generally, okay, generally we take this way, and cos beta will be represented by M, and cos gamma will be represented by N. So there is one more very important point which related for the many problems which we need to solve in the further, okay, that is L square plus M square plus N square will be always equal to 1. How, sir? We'll get for that point also, okay, but keep in your mind L square, M square plus N square. I mean the sum of the square of these all three direction cosines will be always equal to 1. Okay, let's move. How this, sir? Before I go, please just take this triangle AOP. AOP. Okay, I've taken here AOP. So in which right angle triangle, in this right angle triangle, AO already we know that is lies on the x-axis, so x coordinate. AP, that's a point which we get the, if you apply that property which you studied in the first year 3-dimensional chapter, we get AP as a root of x square plus, sorry, root of z square plus y square. Now I want OP, as I said there, OP, correct? So here I want OP. So OP is equal to, apply the Pythagoras theorem. What do you get? Root of x square plus root of x square plus z square plus y square. So root of friends, this cancelled, correct? So now I got root of OP is equal to, I got vector OP is equal to root of x square plus y square plus z square, x square plus y square plus z square. Okay, so that's our never, we will come to this point later. Now you see here, it's a, I'm going to take the cos of this angle alpha. Cos of alpha. Please have a look at this. Cos of alpha. Cos is nothing but what? Adjacent divided by hypotenuse. That means x by r. Cos alpha is nothing but x by r. So cos alpha is equal to x by r means then x is equal to x is equal to r into cos alpha, correct? X is equal to r into cos alpha. So I can write x is equal to cos alpha andre L. So r into L, x is equal to L into r. Similarly, we get in right angle triangles OBP. See, have a look at that old our previous diagram. There will be again two more right angle triangles, that is OBP and OCP. So M is equal to, we get cos beta, or cos beta is equal to y by r, and cos gamma is equal to z by r. So ಇವೆರಡು ಹೀಗಿದ್ದಾಗ then ಇಲ್ಲಿ ಏನು ಸಿಗ್ತದೆ ನಮಗೆ x is equal to LR, ಹಾಗೆ similarly we get y is equal to MR and z is equal to NR. Z is equal to NR. Okay. So now, so we know that this point P is what? X comma y comma z. ಹೌದಾ? Point P is x comma y comma z. So point P with x comma y comma z as coordinate, you can also write it as a x is nothing but LR, y is nothing but LR, so y is nothing but MR, and z is nothing but NR. This is a way also you can represent the point P in space with respect to direction cosines. So dear students, how we got root of L square plus M square plus n square is equal to 1? That's the doubt is there in your mind. We know that vector OP is equal to, let me come back to this point. Vector OP is equal to root of vector OP is equal to vector R, we can take correct. Root of x square plus y square plus z square. So ಹಾಗಾದ್ರೆ x ಅಂದ್ರೆ ಏನು? L square R square. Y ಅಂದ್ರೆ M square R square. N ಅಂದ್ರೆ N square R square, correct? ಈ R square is common ಆಗಿದೆ ಎಲ್ಲ ಕಡೆ. So take it out from root. ಯಾವಾಗ ಇದು ರೂಟ್ ಇಂದ ಹೊರಗಡೆ ಬರುತ್ತೆ ಏನು ಉಳಿಯುತ್ತೆ? L square plus M square plus N square ಉಳಿಯುತ್ತೆ, correct? So now I will cancel these both. So now finally left out root of L square plus M square plus N square is equal to 1. This is the thing which you need to prove. Anyway, I hope it's clear that chapter which you are discussing now. So dear student, please don't neglect this. This is one of the easiest as well as scoring chapter the exam point of view. Thank you, dear students.